Hi fifth graders, it's Mr. Pham again, and today we're going to look at SB pages 33 to 34 from your Getting Ready for the Smarter Balance assessment book. Let's dive into this. Let's look at number 1. Diana worked on her science project for 5 1/3 hours. Gabe worked on his science project for 1 1/4 time as long as Diana. Paula worked on her science project for 3/4 times as long as Diana. Okay, before we determine the amount of time Gabe and Paula worked on their science projects, let's go over some steps for multiplying fractions. Step 1. Let's convert whole numbers or mixed numbers to fraction. Step 2. Multiply across, cross cancel if you feel comfortable doing so. And step 3, simplify. Alright, let's dive right into this. So the first thing we know is Diana worked on her project for 5 1/3 hours. For Gabe and Paula, we need to figure this out to see how long they worked. Okay, so let me grab my pen here and let's choose a different color and let's abbreviate G for Gabe. Alright, so we have Gabe working 1 1/4 times as long as Diana. So since Diana worked for 5 1/3, we need to multiply that by 1 1/4 to determine how long Gabe worked. So again, step 1 is to convert your whole numbers or mixed number to a fraction, and we have two mixed numbers here, so let's convert them into our improper fraction. First, you should multiply your denominator to your whole number, and then take that product and add that to your numerator. For example, 3 times 5 will give me 15, plus 1 is 16. The number stays the same. 4 times 1 will be 4, plus 1 will give me 5. Denominator here is 4. Let's jump to step 2. Multiply across, cross cancel if we feel comfortable doing so. I'm looking across here at the 16 and the 4. I know that both are divisible by 4. 4 divided by 4 will be 1 time. 16 divided by 4 will be 4. Now we can multiply across. 4 times 5, that will give me 20. 3 times 1 is 3. Now let's simplify. We have 20 divided by 3. 3 will go into 20 6 times. 6 times 3 is 18. If I subtract that, that'll give me 2. So my final answer, Gabe worked on his science project for 6 2/3 hours. Alright, and now let's jump in and figure out how long Diana worked on her science project for. Let's pick a different color here and let's write D as our abbreviation for Diana. And here we have Diana, or excuse me, not Diana, Paula. Paula, let's write a P for Paula, not a D. P for Paula. Paula worked on her science project 3/4 times as long as Diana. So we're going to take Diana's time again, 5 1/3. And we're going to go ahead and multiply that by 3/4. Once again, step 1 is to convert your mixed numbers into an improper fraction so you can multiply. Looking at the problem above, we already know that's going to give me 16 over 3. And let's go ahead and multiply that by this fraction here. And what do you know? Step 2, multiply cross cancel. If you feel comfortable doing so, I notice the 3's are across from one another. Let's make that 1. And again, 4 goes into 16 4 times, so this is 1. And 16 divided by 4 will be 4. That'll give me 4 over 1. And that would give me 4 hours for Paula. Alright, so we have here 5 1/3 for Diana, 6 2/3 for Gabe, and 4 for Paula. For numbers 1a through 1d, select yes or no to indicate whether each statement is correct. Let's look at the first statement. Diana worked longer on her science project than Gabe worked on his science project. So they're saying Diana worked longer than Gabe. Well, we know Gabe here worked for 6 2/3. Since 6 is greater than 5, it is a false statement. Let's mark no there. Statement 2. Paula worked less on her science project than Diana worked on her science project. Look down here. Paula worked for 4 hours. Diana worked for 5 1/3 hours. So Diana did work more than Paula. So Paula worked less. This is a true statement. Let's mark yes there. Gabe worked longer on his science project than Paula worked on her science project. Gabe worked for 6 2/3 hours. Diana worked for 5 1/3. That is also a true statement here. And the last statement, we have Gabe worked longer on his science project than Diana and Paula combined. Notice they use the word combine here, which means I need to add Diana's time to Paula's time. Since Diana worked for 5 1/3 hours, we're going to add that to Paula's time, which was 4, which would give me 9 1/3 here. And Gabe worked for 6 2/3. That means Diana and Paula combined worked longer than Gabe did. So this is a false statement here. Let's mark no. All right, moving on to number 2. Now, number 2 states, write each multiplication expression in the correct box, and we are going to determine the value of the product when you're multiplying a fraction to a fraction, multiplying a fraction by 1, or multiplying a fraction by something greater than 1, which could be a mixed number, improper fraction, or a whole number. Okay, so when you multiply a fraction by another fraction, the product will be less than. Okay. Let's go over our second rule. When you multiply, okay, excuse me, let's skip down here, switch the color. When you multiply a fraction by 1, product stays the same. Last but not least, when you multiply a fraction by a number greater than 1, which could be a mixed number, the product will be greater. Alright, so let's go over those rules again. When you multiply a fraction by another fraction, the product is going to be less than. When you multiply a fraction by 1, product stays the same. When you multiply a fraction by a number greater than 1, which is a mixed number, okay, you can deal with a whole number, mixed number that's greater than 1, the product will be greater. Based on these rules and principle, let's take a look at the first one here. We have 4/5 times 1 and 1/8. So we have a fraction multiplying by a mixed number. So that would be greater than. Okay, so let's place that here. We have 4/5 times 1 and 1/8. Okay, moving on. We have 1/3 times 4/5. Here we have a fraction multiplying by another fraction, which means the product should be less than the 4/5. So we have 1/3 times 4/5. Moving on, 3 times 4/5. Again, when you multiply a fraction by a number greater than 1, 3 is obviously greater than 1, then the product will be greater than 4/5. So that's right, 3 times 4/5. Move it down there. Next, we have 4/5 times 4/5. This will be a fraction by a fraction, which means the product will be less than. So let's put the 4/5 by 4/5 right in there. And now, product that's equal to 4/5. Notice that we have 8 over 8 here. So this is an equivalent to 1. 2 over 2 equivalent to 1. So these are expressions that will be equal to 4/5. That's right, 8 over 8 times 4 over 5. And we have 4 over 5 times 2 over 2. Alrighty then, let's go to number 3. Doreen lives 3/4 miles from the library. Sheila lives 1/3 as far away as from the library as Doreen. Okay. For numbers 3A through 3C, choose yes or no to answer each question. Now we know Doreen lives 3/4 miles away, and Sheila would be 1/3 of that. So we have 1/3 of 3/4. To determine the distance where Sheila lives away from the library, we need to multiply here. Notice that we have 3's right across, so let's cross cancel there. And multiply across, that would be 1 over 4. So Doreen lives 3/4 miles away. Sheila lives 1/4 miles away. All right, let's look at these statements to determine whether they are true or not. Doreen lives further from the library than Sheila. That is true. 3/4 is greater than 1/4. Does Sheila live 1/4 miles from the library? We just determined that. That is a true, or we're going to say yes there. Does Sheila live twice being 2 times more, as far from the library than Doreen? No. Doreen lives further, and 1/4 is not twice as 3/4. So let's say no here. Moving on to the next page. All right. So here again, we are going to go over and categorize some of these expressions to determine whether it's going to be equal to the fraction, greater than the fraction, or less than the fraction. So let's get back to these 3 rules. Rule 1, when you multiply a fraction by another fraction, the product will be less than. Fraction by fraction, less than. Second rule, when you multiply a fraction by 1, the product stays the same. Multiply by 1, stays the same. Or a fraction that's equivalent to 1. And the third rule is multiply a fraction by a number greater than 1, which also includes mixed numbers. So we're talking about whole numbers and mixed numbers that will be greater than 1. Or perhaps even an improper fraction that can represent a number greater than 1. The product will be greater. All right, so let's look down here and let's determine where each expression should be categorized. The first one, we have 5/6 times 2/3. They're both proper fraction, so we know that will be less than. Fraction by a fraction, less than. Fraction by a fraction, it should be less than. So we have 5/6 times 2/3. All right, moving on. Here we have 2 times 5/6. Remember, greater than, that would be anything greater than 1. Okay, that would be your whole numbers. That would be your mixed number. And also your improper fraction. So be careful there. Okay, so we're going to categorize our 2/3 here. Or excuse me, our 2 times 5/6 here. Next, we have 5/6 times 4/4. Remember, 4 divided by 4 will give me 1. So that should be equal to, anytime you multiply a factor by 1, it's going to stay the same. So we have 5/6 times 4/4 here. Moving on, and take a look at this one. We have 5/6 times 7/3. Now 7/3 is an improper fraction. Now if you were to rename it, it is a mixed number. Okay, 3 goes into 7 2 times. 2 times 3 is 6. 7 minus 6 will be 1. And 7/3 is equivalent to 2 1/3. But notice this is an improper fraction as well, so it would always be greater than. So here we have 5/6 times 7/3. Moving on to our next one. Again, we have a numerator that's the same as your denominator. 10 divided by 10 will be 1. So that would be the same or equivalent as 1. Let's put it here under the category of product is equal to 5/6. And last, we have 5/6 times 5/6. A fraction by a fraction, again, will be less than what it started with. So let's place that one here. Moving on to number 5. Stuart rode his bicycle 6 3/5 miles on Friday. On Saturday, he rode 1 1/3 times as far as he rode on Friday. On Sunday, he rode 5/6 times as far as he rode on Friday. For numbers 5a through 5d, select yes or no to indicate whether each statement is correct. Alright, so we know, let's jot down some notes of things we do know here. We know Friday, he rode for 6 3/5 of a mile. And on Saturday, he rode 1 1/3 times that amount. So we have 6 3/5 times 1 1/3. Let's go ahead and multiply to determine how far did he ride on Saturday. So first, we need to convert our mixed number into a fraction. So first you multiply, then you add. 5 times 6 is going to be 30, plus 3 is 33/5. Next, we have 1 times 3, which is 3 plus 1 will give me 4/3. All right, jumping on to step 2, which is multiply across. Cross cancel if I feel comfortable doing so. I notice there's a 3 and a 33 here. 3 divided by 3 will be 1 time. 33 divided by 3 will be 11 times. Now I can go ahead and multiply across. I have 4 times 11, which is 44. 5 times 1 is 5. And the last thing I should do is simplify here. I have 44 divided by 5. 5 will go into 44 8 times. 8 times 5 is 40. 44 subtracted by 4. D will be 4. So my whole number here is 8. 4 is my remainder, and 5 will be my denominator. So on Saturday, he rode 8 4/5 miles. On Friday, he rode 6 3/5. Let's determine Sunday now. And let me switch color here. Let's go with the blue. Sunday. All right. And let's go over our statement again. On Sunday, he rode 5/6 times. Again, we are multiplying by a fraction, so it should be less than Friday. Okay, so he rode 5/6 times as far as he rode on Friday. So once again, we have 6 3/5. Now we're multiplying that by a fraction, And we already know the conversion for 6 3/5 as a fraction will be 33 over 5 times 5 over 6. And look what we have here. We have 5 across one another, which makes the cross canceling a little easier for me. 33 times 1 is going to be 33 over 1 times 6 is going to be 6. Now let's simplify or rename this into a mixed number. 33 divided by 6 will be 5. 6 times 5 is 30. And you subtract it, you get 3. So we end up with 5 and 3/6, or 5.5 for Sunday. Okay, so since now that I have all my math completed, let's look at each statement to determine whether it's true or not. Stuart rode more miles on Saturday than he rode on Friday. Let's check Saturday more than Friday. Saturday he rode 8 4/5. Friday he rode 6 3/5. So that statement is true. Stuart rode more miles on Friday than he rode on Saturday and Sunday combined. So I have to combine Saturday and Sunday? Well, if you just look here, Friday he rode 6 3/5. We already know he rode more on Saturday than he did on Friday. So this statement cannot be true. But when I add them up, 8 plus 5, that's going to give me 13. And then I haven't even added the fraction. So that's an obviously no answer. Stuart rode fewer miles on Sunday than he rode on Friday. Sunday, 5.5. Friday, 6 3/5. That is true, and we know once you multiply a mixed number or any number by a fraction, it is going to be less than. So that's an obvious one as well. Stuart rode more miles on Sunday than he rode on Saturday. Also not true because he rode the least on Sunday, only 5.5 there. To our last question. Let's go over this again. We have a fraction by a fraction. That should be less than. So let's move that down here. Next one. Another fraction by a fraction. That should be less than. A mixed number by a fraction. That should always give you a greater product. 4 over 4 times 2/3. Again, this is equivalent to 1. So it should remain the same. Two-thirds times 2, when you're multiplying a number greater than 1, the product will be greater. And last, we have 2/3 times 5 over 5. Again, that's the same as 1. Stays the same. I hope this video was helpful. Thank you for watching. Have a wonderful day. Goodbye.